So you have some idea regarding the important methods used by our municipal authorities as well as water authority or Kerala government for the purification of water. All of you might have heard about chlorination of water. It is one method of purification of water. There are several other methods which we will be discussing in this class. So going to the water purification, there are some certain steps are involved. These are the three main steps which are involved in the purification of water. First is the preliminary treatment, then primary treatment, secondary treatment, and finally the tertiary treatment. Now, as far as the preliminary treatment, it simply means, here you can see that going to the preliminary treatment, when we will be using some kind of metallic screen, and using this metallic screen, you can see that here we will be removing the bigger object like plastic pieces or paper or cloth pieces or metal that will be entering into the water purification equipment. So this kind of bigger items which are present in water has to be removed. That step is known by the name the screening, or which will be coming under the preliminary treatment of water. So here you can see that there are basically two types of screening will be used. One is coarse screen. Coarse screen, here you can see that this is a bigger screen, bigger pore size screen. So this is a very larger type of screen which we call a coarse screen. Whereas another type of screen is known as a fine screening. Here also you can see that will be very small level of the pore size, or the hole size will be very small, and that method is known by the name fine screening. So these are the two important methods which are primarily used for the screening of water. Screening of water is the first step in the water purification method. We have to remove the important, the large size impurities from the water. Then only we can start the actual treatment of water. This actual treatment of water can be divided into three methods. One is primary treatment, secondary treatment, and tertiary treatment. So what is that primary treatment? Here you can see that it involves removal of physical contaminants. Mainly physical contaminants can be removed by number of methods. One such method is screening, another is multimedia filtration, and third type is known by the name membrane filtration. We will be removing the physical impurities or physical contaminants or physical substances present in the water. We will discuss that. So screening, as far as screening is concerned, you have some idea already. Now this is the multimedia filtration. Multimedia filtration is coming under the primary treatment. How we are using this multimedia filtration? So this is the apparatus or device used for multimedia filtration. Multi means many. Media means different type of material. So here you can see the different types of materials are used. One is an anthracite layer, another is a sand layer, another is two layers of garnet is used. Then at the bottom there is a layer of gravel. So there is a big tank like or cylinder like apparatus will be there, and water will be pumped into this tank from the top under high pressure. As the water is moving through these different layers of material or these different layers of media, there will be gradual filtration of water in a step-by-step manner. So that process is what we mean by multimedia filtration. For example, you can filter water using sand alone, because if water is passing through in an aquarium, that is what we are using. We will be putting sand and water is passing through the sand, it will be filtered. The same process is being used here also, but in addition to sand layer, we are also using some other material like anthracite, a kind of coal, then garnet, and also gravel. Gravel is a metal piece are also used at the bottom. So in this, it is a modern physical wastewater treatment which uses three layers of filtration: anthracite, sand, and garnet to eliminate the water contamination. So this is how the system will be working. There will be a large tank or a cylindrical tank will be there. Very under high pressure water will be pumped into this tank. As the water is moving through the different layers of this material, there will be gradual filtration. Then what advantage is in this wastewater treatment process, particle having a molecular size of 10 to 15 micron get removed. So what is a 1 micron? 1 by 1000 of a millimeter is a 1 micron. So material which are much smaller than even 1 millimeter can be removed, that is up to the size of 15. If the size of the particle is 10 micron, it will be removed. Only if the size of the particle is less than 10 micron, it won't be removed. So by this method of multimedia filtration, we will be able to remove most of the bacteria, viruses, fungi and other kinds of materials also. So this is an advantage of multimedia filtration, and as we have told you in the beginning, multimedia filtration is a kind of primary treatment. In a primary treatment, we will be mainly focusing on physical contaminants or removing the physical impurities from the water, and for that we are using screening. Here you can see it's a process used for removing bigger particles, whereas multimedia filtration is used for removing particles which are of size above 10 microns in size. Now next method is membrane filtration. Going to the membrane filtration, the method is somewhat similar also. This is the membrane filtration, how the membrane, this is our membrane filtration. In all these steps there will be number of important mechanisms are there, but whatever be the mechanism, there will be a membrane like this, and water will be passing through that membrane. And just like when we are sieving water, sieving our tea or coffee using a sieve, we are using a net-like structure. So when the water is moving through that membrane, which are like a net, it will be removing most of the materials, impurities. So physical wastewater treatment, which eliminates water contamination with the help of a membrane, is known as a membrane filtration. So when we are using a membrane, so here you can see that membranes will be very small, having a hole size of having very small hole size. Here you can see the different types of membrane filtration is there. If the hole size, what is the pore size? Pore means the hole. Pore means hole. If the pore or hole size is between 0.1 to 10 micron, we call that kind of membrane filtration as microfiltration. Now second is the pore size is slightly more smaller. It is between 0.05 to 0.01 micron. Then we call it as ultrafiltration. Again, if the pore size is again smaller, 0.005 to 0.001 micron, it is known as a nanofiltration. So that is, so whether it is microfiltration, ultrafiltration or nanofiltration, it is a filtering of water through a membrane. And based on the size of the pore, we are classifying it into microfiltration, ultrafiltration and nanofiltration. Advantage of nano means very fine level. Here you can see it will be even capable of removing or eliminating ions such as calcium. So you can imagine what will be the size of a calcium ion. It will be very small. Even those smaller ions can be removed by using nanofiltration. So that is the advantage of membrane filtration. Then we have one more topic of technique known as reverse osmosis. Nowadays, if you purchase a water purifier, sometimes they will be written RO. What is this RO? They will tell it is a reverse osmosis. But most of you may not be having any idea how this reverse osmosis may be taking place. In your high school classes, you might have studied about osmosis. Osmosis simply movement of water from across a semi-permeable membrane from a higher concentration to a lower concentration. It is a definition you might have studied in your high school as well as +2 classes. So it's simply, so there we are moving water from its higher concentration to its lower concentration through a membrane. That membrane is known as a semi-permeable membrane. But in a reverse osmosis, what we are doing, we will be just doing the opposite. We will be pumping water from its lower concentration to its higher concentration. then we call it by the name reverse osmosis. So normally, if the normal osmosis is not we don't need to use a lot of energy, because it is in the natural path from its higher concentration to its lower. It's a natural flow of water. But if we are pumping water in the opposite direction, we have to apply a lot of energy, and that process is known by the name reverse osmosis. Advantage of reverse osmosis is that it is capable of removing very smaller particles. Like if the here this reverse osmosis, the pore size will be 0.005 to 0.0001 micron, very fine pore size. So that is the advantage of. Here you can see that reverse osmosis can remove ions such as calcium, bacteria, virus, and most of the other contaminants. So if you when you are buying a water purifier, based on the cost, if you spend only some 5,000 or 6,000, you will get a normal water purifier. But it will be only UV. There will be UV bulb, and if you are keeping the UV bulb open, some bacteria may die. Most of the bacteria and virus may not die. But if you go for a RO technique, in the case of RO technique, there is a membrane like that. While moving through that membrane, most of the bacteria, virus, and other even divalent ions can be removed by this RO technique. So that is why reverse osmosis is more effective as a water purification technique. And also how this reverse osmosis is actually being done. Here you can see that there is a pipe inside there, through that water will be moving. Then there will be a membrane which are covering, several layers of this membrane will be there. As the water is moving through this membrane, most of the impurities will be removed. So this is a idea regarding how this reverse osmosis is actually taking place. Now here you can see that RO technique is being employed in a very large scale. So here this is a factory like a bigger setup. Now if you want to purify water for an apartment complex of 1,000 people, 1,000 apartment or 1,000 families, you need a heavy water purification, very highly complex water purification setup. So here this is what you are seeing. So in the case of this kind of heavy set complex setup, this is how the arrangements will be. And inside these all tubes, this white tube, there will be set up like this. This is a miniature setup, and same setup has been extended into a larger scale here for industrial level or apartmental level purification. So this is the technique that we are using for RO purification and other kinds of water purification. So these are the different steps which are mainly used in the primary treatment. So either it can be screening, multimedia filtration, or membrane filtration. Then comes the secondary treatment. Now what is secondary treatment? It involves removal of suspended solid. For example, if you keep a glass of water, there will be some particles in that. For example, during the rainy season, if you collect water from a river, or most of the time that river water will be yellow or sometimes orange in color. Why? There will be a lot of dissolved or suspended soil particles in that. And if you keep that water in a glass for 1 hour or 2 hours, after some time you can see that most of the soil will be settling at the bottom of the glass, and the top portion will be more consists of clear water. So this process is known by the name sedimentation. Now in the case of secondary treatment, we are mainly employing this technique. We will be removing what are the main suspended particles which are floating in the water by use of sedimentation, and about which we are now going to see how the secondary water treatment is going on. See here in the use of the secondary water purification, you can see that there are 5 different steps are involved. And these 5 different steps are coagulation, sedimentation, filtration, disinfection, and storage of water. And here you can see these steps in a graphic, diagrammatic way. The first step is known by the name coagulation. And here what we are taking, we are collecting water from well or from lakes or from rivers and pumping this water into a tank. So that is what is happening here. Then what are these smaller tanks here? And special compounds will be added into the sedimentation tank here or coagulation tank. And see, the first step is known as a coagulation. Alum sometimes you might have seen, it's a white color material, stone like marble like material. That alum will be added into the water. And effect of alum is that it will be causing coagulation. Coagulation means very small particles will be coming. For example, this is when alum will be added, these kind of smaller particles will be, this is a smaller particle, this will be coming together and sticking with each other. So that is the effect of adding alum into the water. They will be causing sticking of water particles, sticking of solid particles with each other. When they stick together, the weight of the particle will increase and they will go down and settle at the bottom of the tank. So this process is known by the name coagulation. Alum is a chemical that stimulates this sticking or coagulation of particle. As a result of coagulation, these particles will be settling at the bottom of the tank. So here you can see that when we are adding alum, it will be causing coagulation. As a result of coagulation, the second process comes into effect, that is sedimentation. The heavy particles settle to the bottom of the treatment tank, allowing for their separation from the tank. So as a result of addition of alum into this coagulation tank, after some time you will be taking that water into the next tanks, which are known as sedimentation tank. In the sedimentation tank, these kind of bigger particles will be more settling, sticking with each other, and they will be finally settling at the bottom of the tank. So that is done by the name sedimentation. So after sedimentation of the particles, the water becomes more and more clearer. So here you can see more suspended particles are here. Here less suspended particles are here. Here most of the particles have sedimented or settled at the bottom of the tank, and water becomes more clear. That clear water will be taken by a water pipe and taken to the next level, that is a filtration level. So in the case of filtration level, water passes through filters of sand, gravel and charcoal to help remove even smaller particles. 3 layers of filtration. First is sand, charcoal, gravel and charcoal. So 3 layers of filtration tank will be there. When water is passing through this, see, the first layer is a sand. So the water will be pumped at the top of the sand, and water is moving through the sand downwards. The lower water will be collected, and that will be taken to the next tank, that is a gravel tank, where water will be again pumped at the top of the tank. It will again, the filtered water will be collected from the bottom and taken to the charcoal. Charcoal has the effect of removing most of the smell causing particle. So that is why we are using charcoal, and that particle, that filtered water that has been filtered by charcoal filtration will be taken by pipe to what we call another layer called disinfection. Another tank will be there. That tank is known as a disinfection. Here you can see the filtration will be finished and that water will be taken to another tank that is known as a disinfection. There we will be supplying disinfection. The most common material for disinfection is the chlorine. So here you can see that we will be adding chlorine into this water, into this tank. Here also you can see that we will be adding chlorine into the disinfectant, into the disinfectant tank. So the water will be allowed to remain with the chlorine for some time, so that bacteria that will be present in the water will be killed. So even after sedimentation and filtration, bacteria may still be present in that. So by adding chlorine into the water tank, our advantage is that chlorine will be removing most of the harmful material, most of the harmful bacteria from the water. Chlorine is a highly oxidizing or a bacterial killing agent. So by adding chlorine, the chlorine will be capable of destroying most of the bacteria. That is why we are adding this kind of we are keeping a system like this. So along with the chlorine, there are other kinds of chemicals are also used. Sometimes ozone will be used. Sometimes hydrogen peroxide will be used. So any kind of chemical which has a capacity of destroying bacteria can be used as a disinfecting agent. Now what is the last step? That is storage. So during the storage, water is placed in a closed tank to allow for disinfection. The water will be then collected into the water storage tank. There it will be kept and will be pumped into the municipal water supply system, so that the water will be finally reaching our house or other industrial areas. So this is how the water purification is actually being done in a several step by step manner. So now what we have to see is the why. So here we can see that this is the third step, that is secondary water treatment. Then comes the chemical process that does it for the final treatment. So this is the last step, that is a tertiary treatment. Here you can see that we can go for disinfection. The disinfection is normally done by chlorination. So we have to see how this chlorination will be conducted during a water purification technique. Here you can see a picture. Chlorination is that it's a very strong oxidant. That's a powerful oxidizing agent. It's a poisonous gas, toxic gas. So it has to be used in a very careful manner. So there is danger of release. When we are using chlorination, the chlorine gas can be produced. That chlorine gas is always dangerous. To avoid that problem, we are actually using sodium hypochlorite. Sodium hypochlorite is more cheaper and it releases free chlorine when dissolved in water. So that is the advantage. So we are not directly supplying chlorine gas. We are actually adding sodium hypochlorite that will be producing chlorine in the dissolved when dissolved in water. One drawback is that chlorine from any source reacts with the natural compounds in the water to form harmful chemical byproducts known as trihalomethane, THF, and haloacetic acid. So problem with this trihalomethane and haloacetic acid is that they are cancer causing substance. So we have to reduce the formation of this trihalomethane and haloacetic acid, and for that this trihalomethane and haloacetic acid will be formed only if water is containing some organic material. What are the normal organic material? Any kind of plant material or any kind of animal remains. So the water that is reaching the disinfectant tank should be filtered off, should be filtered of all kinds of organic material as well as inorganic. It is absolutely clean water that should be reaching the disinfectant tank. Otherwise, what happens is that this process of formation of trihalomethane as well as haloacetic acid will be occurring, and that is dangerous for human health. So that is a problem of, so the formation of trihalomethane and haloacetic acid may be minimized by effective removal of as many organic compounds from water as possible before the chlorination. So if the water is fully treated, completely removed of physical impurities, then it is safe. Then we don't need to worry about the formation of haloacetic acid or trihalomethane. That is why before the filtration, this kind of before the disinfection, this kind of various steps are involved, like coagulation, sedimentation, and filtration. 3 layers of filtration is we are employing here. The purpose is that water should not contain any physical, biological impurities in that. If any kind of biological impurities are there, that will lead to the formation of these two chemical, haloacetic acid and trihalomethane, which are highly undesirable or dangerous for human health. Although chlorine is effective in killing bacteria, this chlorine is not always effective. Sometimes it has limited effectiveness against protozoa. So you might have studied about protozoa. It is different from bacteria. Protozoa is an entirely different type of organism. For example, then cyst in water, like Giardia lamblia, Cryptosporidium. So the exchange or the cyst stage of this reproductive bodies of this stage is known as, are also not destroyed by using the chlorine. So that can also, there is a slight possibility of infection still if these organisms are still present in the water. So what we are doing is that this is how the chlorination of water will be undertaken. Sometimes in addition to chlorination, we are also going for another technique, that is ozone disinfection. So in the case of ozone disinfection, ozone is a highly unstable molecule. So you know that oxygen is O2. If you add one oxygen atom to the oxygen molecule, it becomes O3. That O3 is known as ozone. So it is a highly unstable. That means O3 cannot remain like that for a longer time. Whenever O3 is there, after some time it will be splitting into O2 and O. So that splitting process will be releasing one oxygen atom. That oxygen atom can destroy anything. So that is how the oxidizing agents are usually working. They will be releasing a free atomic oxygen, and that atomic oxygen can cause damage or destruction to most of the bacteria or other kinds of material. So this is how the ozone is actually working. So it is a very powerful oxidizing agent and is poisonous or toxic or dangerous to most of the waterborne organism. So it is capable of destroying the protozoa. Here you can see that in the use of chlorination, it is not very effective against protozoa. But ozonization is capable of destroying the harmful protozoa and their cyst also. So that is one advantage of ozone disinfection. Some of the advantages of ozone include production of fewer dangerous products in comparison to chlorination. For example, when we are using chlorination, there is always a possibility of formation of trihalomethanes or haloacetic acid. But such possibilities are not there in the use of ozone disinfection. There is absolutely no byproducts are formed, no dangerous byproducts are formed, and there won't be, for example, if you are tasting a pipe water which are supplied by our Kerala water, it has a different taste than a taste of a water that you collect from a pond or a well. So chlorinated water definitely has a peculiar taste. Some people may not. For example, people especially living in a rural area, when they go to town area or city area, they say that water is chlorinated, it tastes different. So that is a problem of the chlorination. But in the case of ozonization, there is no special taste for that water. Lack of taste and odor. So chlorinated water do not have any taste or do not have any smell also. Although fewer byproducts are formed by ozonization, it has been discovered that use of ozone produces small amount of suspected carcinogen. There is a cancer causing known as bromine. Although little bromine should be present in the, so there is a rare possibility of formation of calcium bromide. So that is also, no chemical is absolutely safe, whether it is chlorination or ozonization. It depends on how we are using it. Another main disadvantage of ozone that it leaves no disinfectant residual in the water. What is this residual disinfectant? For example, when we are treating a water with ozone, and we have treated water with ozone today, and we are supplying water to the homes, and the water may be reaching our home maybe after 1 day or 2 days. But during the course of this travel, if any bacteria or protozoan is entering into the water pipe, then that bacteria will not be dying, because the ozonization is only for that moment. But in the use of chlorination, some amount of chlorine will be still present in water. So even if bacteria or virus is entering in that water body, after a water system, after 2 days or 3 days or 1 week, the chlorine that is remaining in that water will be still killing that bacteria. That is one important advantage of chlorination. Chlorination can the water which is treated by chlorination can keep that the disinfected activity for several weeks. So that is an important advantage for Kerala Water Authority, because they can ensure that water is still of good quality because of the presence of certain chlorine remaining or in the water they have treated. So this is known as a residual disinfectant. So in the case of chlorination, residual disinfection is always a possibility, but ozonization doesn't have that possibility. So this is how we are actually giving ozone. We will be taking water into a water tank, and we will be releasing ozone gas into that water, and after that it will be collected by another system. So ozonization is actually done by this process. Here also you can see how the ozone is forming. This is the O2 and this is the ozone. This molecule is highly unstable, releasing this oxygen, and this process is known as oxidation. Then another technique is ultraviolet disinfection. In the case of, for example, if you are buying a very low cost water purifier, it usually has ultraviolet. Ultraviolet is not very effective because it is only effective against cyst, and it can only work in water which is more clear. For example, water is full of impurity, suspended particle, high turbidity is there. Then ultraviolet disinfection may not work because it is working on based on light. When light is not able to reach certain area, it will not be effective. So ultraviolet light disinfection by penetrating the microorganism and destroying the DNA. For example, if we are showing ultraviolet to a bacteria, the UV rays will be entering in the bacteria through its membrane, arranging the nucleus and destroying the DNA. That is how the ultraviolet or UV disinfection is normally working. But the problem with the UV disinfection is that it is not very effective, but it is cheaper. That is why low-cost water purifier always have this UV kind of disinfection. So, but no bacteria, virus, mold can survive it, because if the water is very clear and not containing any suspended particle, it can be effective and it will be capable of destroying most of the bacteria, virus, mold or their spores. So this is how the UV ultraviolet disinfection. Here you can see a picture. So this may be very familiar to you, because wherever we are purchasing a low quality, low price water purifier, this is the system. There will be ultraviolet bulb will be there, that will be, and water will be collected in this tank, and when ultraviolet bulb is turned on, the water will be it will be releasing UV light that will be destroying most of the bacteria. So this system is known by the name UV disinfection. UV disinfection is also work based on the release of this hydrogen gas. Hydrogen will be escaping by this. Water will be splitting into hydrogen and oxygen. So this is how the UV disinfection is actually working. Then hydrogen peroxide disinfection, which is the last one. In the case of hydrogen peroxide, this is the hydrogen peroxide molecule. So hydrogen peroxide is also a highly unstable molecule that will be splitting into water and oxygen, and this oxygen can act as a oxidizing agent, destroying most of the bacteria or other kind of pathogenic microorganism. But in the case of hydrogen peroxide disinfection, it has also its own disadvantage. That is why it is not very popular. Its disadvantage is that it is very slow working. Action is very slow. Phytotoxic. Phytotoxic means toxic to plants in very high doses. Then decrease the pH of water. For example, if you are using hydrogen peroxide disinfection, a neutral water which has a pH of 7 can become turn more into acidic water with a pH of 6.5 or 6. So that problem is there with hydrogen peroxide disinfection. That is why nowadays hydrogen peroxide disinfection is not very popular. Mostly ozonization and chlorination are the normal techniques used for water purification. Then second problem is that we have to use high dose of hydrogen peroxide. In a low concentration or lower dose, hydrogen peroxide disinfection will not work. Then there is also one more problem. Another problem is the decomposing hydrogen peroxide in water and presence of oxygen radical. So this hydrogen peroxide will get destroyed very quickly or decomposed very quickly. So compared with the chlorine, bromine, ozone and other, hydrogen peroxide is not very powerful. So that problem is that it is not highly effective compared to the chlorination or bromination or ozonization, but still it can improve the disinfection ability of other. So a multi-level approach may be more. For example, chlorination alone may not be completely capable of destroying most of the bacteria. Along with the chlorination, if you are also going for ozonization and UV method, then we can ensure that water will be removed of, or most of the bacteria and virus which are maybe present in the water will be completely destroyed or removed. So this is an idea regarding the different methods that we are using in water purification. Mainly three methods are the, and we have to explain what are the steps involved, what are the mechanism involved in three primary methods, like these methods are primary treatment, secondary treatment and tertiary treatment. So this is the end of that.